check the recorder because I recorded one silent movie once this semester. And let's see. Let's go. And I'm gonna adjust the monitor, make sure it's all showing. Oh, I found a few cool things. You know, I know we are running out of time, but this is really, really cool. One is called a circuit scribe. And I was pointed to this by someone who knew me fairly well, and I think some of you may actually appreciate it as well. So this is I'll show you the video. It's actually pretty cool. So it's basically, you know, conductive ink, and you can use it to draw out a circuit. And then they make these components you can place on a piece of paper and use the conductive ink to actually, you know, create the circuit. Whoa. So when you guys move on to your, you know, 4-year university and you are taking electronic lab classes and whatnot, and your professors, you know, tell you, oh, you have to use breadboards, you know, which is a really old way of doing things. So you have to put in wires to make connections and stuff like that, and the wires will get loose, and you will basically your stuff doesn't work anymore. You can point your professors to this kind of thing and say, we can do it on a piece of paper. We can make a circuit on a piece of paper. Just don't do anything that's a power circuit. That's the only thing. Like, you know, 20 amps may not be a good idea. Yeah, just make sure, if you want to do that, make sure you have fire insurance, proper fire insurance. But anyway, it's really cool. You know, I think some of you may get a kick out of it. I have not ordered it yet, but I'm thinking about it. Because it's really good for prototyping stuff, you know, just, you know, testing out, you know, is this circuit going to work? You know what? I know exactly what I should do with this. Next year, instead of using Logitsim, we'll be doing that. People actually have to turn in a computer on a piece of paper with all that circuitry. That's it. Okay.
What if you can't draw? What if you can't draw?
What if you cannot draw? Well, you don't have to draw really straight. You know, relatively straight is fine. Well, you know, there are other issues with drawing, you know, a circuit too, because, you know, you only get, it's difficult routing. Actually, this is a good exercise because, you know, then people start to understand the issues of routing, which means, you know, how do you make all of those connections, but on a two-dimensional kind of thing. Because in this class, when we deal with Logitsim, you guys don't have to worry about it, right? The connections are all logical. I want this point to connect to this point to connect to that point, and they can cross path, okay, without any issues. But in real life, when you design a circuit board or when you design a chip, you do have a lot of constraints because you cannot have crossovers. So yeah, that's actually a pretty interesting thing to talk about. But most people don't really need to worry about that. All right, so getting back to the homework assignment. Yep.
Are you recording?
Yes, I think I am. So the recorder is on, and according to this, it is recording with voice. Yes.
Thank you, Mickey.
That's good. You guys learned the lesson. All right, so this is the homework assignment. You have to implement string D copy. So I think the question has to do with what string D copy actually does, and what we'll do is to let me see if the source code is still in my home folder. strdcpy. Yep, I still have it, so that's good. And if we look at string dcopy.c, okay, this is, oh, I guess not. Oh, because I changed it to underscore. Okay, there we go. So this is the behavior of your code. Your code has to do the same thing as this. Okay, whatever it is, your code has to do exactly that.
Specifically the...
Let me try on the line number so you can refer to line numbers.
That would be great.
There you go.
Line 7, the function within the while.
Right.
Check. Like, when we go and we look at your other one, it's going and checking for those two things now. I believe in the actual, or what it should be doing is it's going to track down.
No, you're going to make a call. You're going to call string char in your assembly code.
Okay.
So what you need to do is in your assembly code, you will call string char with those two arguments. The first one being delim, which is the string with all the delimiters, and then the second one is whatever source points to as a character. So your code will do exactly the same thing. So you don't even have to really think about what string char does, although understanding what it does is going to be helpful. But your code should be doing exactly just that. So if you do like a mirror of this code here, your subroutine should be fine. But understanding what it does is important, it's useful as well. So string char as a function is going to return a pointer, a non-null pointer, if the second argument, which is supposed to be a single character, is found in the string, which is the first argument. Then it's going to return a pointer to the character in the first string. If this character, the second argument, is not found in the null terminated string as the first argument, then it returns a null pointer. But as far as we are concerned, we don't even care about where that character is in delim. We just need to know, is it in delim? So we just need to know whether it returns null or not. And that's why when you look at how we apply the negation operator on the outside of string char, this is all we need to know. Did it return null or not? And that will help you determine whether to exit the loop or stay in the loop. Is that okay? So, quick reminder, how do we know what string char is returning when we are coding this in assembly? Okay, a few options, multiple choice, okay? Is the 0 flag indicating that? 2 is EAX indicating that. 3 is, I don't know, EBX doing that. So what do you look? EAX, okay? EAX is the return value of anything that returns a scalar. A pointer is considered a scalar in this case. Okay, any other questions? No other questions? Okay. How would you do this? If you're still in the process of writing this subroutine, how would you get started and how would you do it step by step?
I always write a pseudocode for it first.
Write a pseudocode, or you can just flatten this code in C++. Okay? Does everybody still remember what is flattening structured code? You turn a loop or structured conditional statements into the one format that we have talked about before. It looks like this. It's a conditional statement, but it is a very specific kind of conditional statement. It is an if condition with only a single comparison in the inside here. And then the only statement, the only then statement is a go to a particular label. Okay? So you want to only have this type of structure or this type of way to divert the execution path to whatever label that you define somewhere else. So you want to use only this kind of construct. You probably end up having to use like many of these things, but the idea is to flatten the structure so you don't have a loop anymore. You don't have a while loop anymore, and you only have this sort of thing. Because once you boil down your program once you flatten the program to this, then you're ready to implement the program in assembly. Is that okay? Is that making any sense? Sort of? Okay. But the best part of flattening the program first before implementing the program in assembly is a flattened program in C++ should still behave exactly the same way as this code here. So you can cross-check your actual logic before you try to implement the program in assembly. In other words, I'm trying to get you guys to defer the conversion into assembly code as much as possible, because debugging in assembly is not going to be as easy as debugging in C or C++. So I want to help you guys defer that process as much as possible. Is that okay? Second thing, so let's just say that you do have this code completely flattened. In other words, you have only this type of construct. If some kind of comparison, a single comparison, go to a single label, okay? So everything is now flattened, and you check your code and it's working 100%, okay? So you're ready to convert this program into assembly. How do you convert it into assembly so that you know that at least from the perspective of accessing the local variables and the parameters, your subroutine is not having issues with that? You can use GDB, but I would not even write a single line of code as far as control and actual assignment is concerned. I would write a stub, okay? And I would just move the parameters into registers, and then you can run your code through GDB to make sure that the registers contain what should be in the register, you know, when you convert it into assembly. Let me show you what I mean exactly by that, okay? So let's split it, and in the bottom half, I'm going to, actually, let me quit, see if I can do a vertical split, because that would, there we go, it makes sense. I actually did not know that command vsplit. I just thought, hey, vertical split, vsplit, okay, seems to make sense. So if I were to implement this in assembly, okay, which I already have something like this, this is not good enough, okay? It is a good starting point, but it's not good enough. If I were to do this, I would do this first, okay? If I have a kind of some kind of doubt or potential misunderstanding of, you know, how parameters are arranged on the stack, this is the first code that I would write. I would put a breakpoint on line 3, the return instruction itself, so that when we call this subroutine, it will stop. And then I would examine what is on the stack, just so that I can find the 3 parameters on the stack and I know exactly where they are. Is that making any sense? So I would verify that first, okay? And then what I would do is to put in the usual entry code and the usual exit code. And inside the program, so I'll give you more information about that. So I would put the usual entry code over here. I would put the usual exit code over here. But inside here, I am going to do some, something that is not really, doesn't seem to be useful, okay? So I would use, I would move the parameter first the parameter into EAX. I would move the second parameter into EAX, and I would move the third parameter into EAX, and I would put a breakpoint on these instructions. So at this point, now param1 obviously is not what it is supposed to be, okay? You guys need to think about what kind of addressing mode you need to use, and how to calculate the displacement of each parameter from a particular register that is really useful in this type of situation. So I'm not going to give that away right away, okay? So you guys have to think about that. But the idea is I want to put breakpoints on line 4, 5, and 6 so that you can verify and say, okay, I think I got the first parameter. I think I got the correct second parameter, and I think I got the correct third parameter. Because until you know that you can get to the parameters correctly, writing any code in the subroutine is pointless. Is that making any sense? Because if your program does not work, if your subroutine is not working, do you know whether it is because you're not getting to the parameters correctly, or do you think it is the logic of the code that is incorrect? So you need to rule out the possibilities by confirming that you can at least get to the parameters correctly first before writing the logic of the code. Yep?
How do you put the breakpoint inside the stub if you open the CSV file
I'm not really sure what you're asking. So are you asking, okay, so if I have some no-op instruction here, are you asking how do I put a breakpoint on one of the no-op instructions?
No, if you call this function from within the C code,
yeah,
and you open the C code, how do you put the breakpoint?
I will show you that. That's because, okay, that's because when you set up a breakpoint, just like when you're listing, you can specify which file and which line on that file, in that file. So I'll show you about that. Okay, so I'm gonna make, I got a make file already set up, so this is, it's easy. So I can gdb main. So what you can do is to list a particular file. You can, when you say L, it is automatically defaulting to where you're going to execute next, which is on line 10. So what you can do is to say, oh, I don't want to list this file. I want to list, string d cpy dot uppercase s. Okay, fine. That doesn't work. There we go. So you have to give it the file name and a colon and a line number. Okay. Now you can look at the content of another source file. Is that okay?
Okay, so L file name and a
colon and then a line number. But you can also use the same method. Instead of an L, you can put a B to set up a breakpoint. So I can set up a breakpoint on, say, line 6, which is the second no-op instruction. Now when I run the program, I'm now stopped at line 6 in this program. Okay, and since I'm here already, I might as well also show you what I would do. At this point, I'm going to show myself. Okay, what is ESP and what is EBP? Okay, but remember, I don't even have my entry code and exit code set up at this point, so EBP is not really useful to me the way it is right now. Okay, because the entry code has to do something with EBP, but ESP is still useful because I want to see what is on the stack. The examine command combined with 4 or 5 items on the stack can be very useful. So now I can say, okay, show me what is on the stack right now, and I can see these entries here. The first thing you might notice is, oh, this does not look like the other items. That's because this is a return address. Okay, this is the address of the instruction. When the subroutine is done, this is where we go back to. What about these 3? I don't know what those are. Okay? Well, if you don't know what those are, what do? Do they look like addresses to you?
Yeah.
Well, they do look like addresses because the stack pointer is about the same. Look at the stack pointer. The stack pointer definitely contains an address on the stack. That comparing to this is close. Not exactly the same, but pretty close. Okay? So then you think, oh, we do have 3 parameters that are pushed on the stack, and each parameter is a pointer, right? And not only do we know they're pointers, but we know they're pointers to characters, they're strings, no terminated strings, right? So the next question is, can we look at this as a string and find out what is in that string? Is it really the first parameter? How do we know that? Well, there are several ways to do it. The first way is to say help X, because X can display strings too. So you can say, instead of using W for 32-bit integers, you can specify S for string. In other words, treat the following as the address of a string. Okay, so we'll do that. We'll do exactly that. So let me repeat the previous command. Look at the items here. So now you can say x/s. Okay, I've never done this before, but it shouldn't be that hard, right? Okay. Just copy and paste it, and it shows you. That's not a. That is supposed to be a string, but it's showing you just a hexadecimal. Okay. That's correct because this is the destination. It is uninitialized. Okay, so this is all good, and we can look at the second string, which is supposed to be the source. Oh, should have just kept this thing here. Okay, this is the source. This is what I typed, from standard in, and we can look at the last one, which is a string of all the delimiters, and that one is at 0C0. Okay, does it look right to you?
Yeah.
Those are our delimiters. Okay, so you can use GDB to really help display all the items on the stack and have a much better understanding of how parameters are passed. Which one is my first parameter? Which one is my second parameter? Which one is my third parameter? And so on. Okay, but you still have to learn how to use EBP to make this program easier to implement. Is that okay? sort of. Okay. What about calling a subroutine in? Yeah, go ahead.
When you allocate space for the parameters in a subroutine, does it copy the address to the values, or does it actually import the values of the parameters in the allocated space?
But there's no such thing as allocation for the parameters. Okay, who is responsible to put the parameters on the stack? The caller or the subroutine being called? The caller. And how does the caller, put all those items on the stack? Typically, they're on the stack, right? So how do you put something on the stack?
Last in, first out.
Last in, first out is the ordering, but what instruction do you use to push? Exactly. So I'm not quite sure about your question.
So the caller can push whatever he wants. He can push the values or the addresses.
It depends on what the parameters are, right?
Uh-huh.
Do we know the C code responsible for this part? Okay. And how do we know who called this? Backtrace, right? So we are in string copy from main, so we can go back to main and say, okay, show me the code that's responsible to push these 3 items. This is the call, this is the function call, and those are the parameters. And by the way, what is dest? D-E-S-T. It is an array, right?
Address of the
Exactly, because in C and C++, you cannot pass arrays by value, so you have to be passing it by address. Same thing with source, and same thing with delim. Now, how do we know that? Okay, so in GDB, it gives you a way to go back to a previous frame. So I can say frame 1. So now I go back to frame 1, which is in main. And in main, I can say print source. Okay, I can say print destination. I can say print delim. But that's not really that helpful. Okay, what you can also do is to say print the address of source. Okay, do we recognize this?
Yes.
And when did we see this?
On the stack.
On the stack, exactly. So by using the GDB commands, we can now examine, the stack. We can examine the C code. We can examine, all kinds of stuff to basically say, okay, I have a question about blah blah blah. Okay, and this is how to kind of dig into it and get a better understanding.
So those values that are parameters for the called function, those are the values that are getting pushed on the stack.
Yeah.
Okay.
But that's the whole idea. We are passing parameters on the stack.
Yeah.
Yep.
Okay.
All right. And the C code is expecting the same thing. So when you call string char from your assembly code, you have to push the arguments on the stack before the call instruction. Okay. Any other questions? Have I demonstrated the swap subroutine in this class? Because that's a pretty useful subroutine to show you how to access pointers and indirection and stuff like that. So let's do that, okay? It is not remotely resembling your homework assignment, but it is still helpful. Okay, so as usual, I'll write it in C first, okay? So in C, the swap subroutine will return a void because there's nothing to return. And instead of using passing by reference, I'm going to use pass by pointer because this is actually closer to the actual mechanism of passing by reference. So the first one is pointer to x, pointer to a particular integer x, and the second one is py, which is also a pointer. Are there any questions about the types of the parameters? Px is a pointer to an integer, py is a pointer to an integer as well. Okay? So inside the code here, it is not really that hard. Okay, I have to remember the first thing first. Whatever px points to, I have to remember it into my local variable t, and then I can change it because once it is remembered, I can now update it and use this usual sequence of 3 assignment statements to swap the content of whatever px points to and the content of whatever py points to. And in main, I would declare two variables. Well, x, y is fine. And I say x equals to 5. Oh, okay, 5. Y equals to 7. Swap whatever x has with whatever y has. Okay? I'm taking the address of x and the address of y. And return 0. There we go. Are there any questions about the C code? Going once, and twice. Yep.
Is there any big difference between I understand two styles between passing by pointer and passing by reference. When is which one preferred, or is that about the same thing?
Passing by reference is preferred if it can be done.
Okay.
Right, but in this class, we use passing by pointer because C does not have pass by reference. Only C++ has pass by reference. So it's a C++ feature. But it really is doing the same thing behind the scenes. Okay, so all kinds of pass by reference methods in different programming languages is still pretty much passing the actual address of whatever you're changing, with the exception of scripting languages in which they pass the handle or a reference instead of the pointer. Okay, but in low-level programming, they're always just passing the address of whatever needs to be changed. So this is actually much closer to the actual assembly implementation compared to passing by reference. Okay. So this is the C code, and then we'll do a V-split, okay, and say, okay, but can we do this in assembly? So we'll go ahead and create a new file called main.uppercase-s, and we'll convert the entire program into assembly, not just main, but also swap. Okay, so we'll start with, in this case, I only have to export main because that's the entry point of the entire program. So we have a subroutine called swap, and here's the return. But before I do anything else, I would assign labels, symbolic names to the offset or displacement to each parameter as a number of bytes of displacement from where EBP points to. So in this case, I have a return address. Oops, no, OEBP being 0, because if I set up my call frame correctly, EBP should point to its own old value. Okay. The next one is the return address, which is actually pushed by the caller, not by the callee. And then we have our first parameter. And then we have our second parameter. Okay, so I just use these symbolic names so that it's easier for me to keep track of stuff. Yep.
I know it's kind of redundant, but the equal 0, does it allocate nothing at all, or what is?
No, it simply defines the label old EBP to be the same as 0. It literally defines the symbol old EBP to be 0.
So the value of old EBP address?
Old EBP as a label is the same thing as 0. This is how we define the values of a label. This is how we make label definitions, or one way to make label definitions. Okay. So from here, I can now use the usual entry code. The first thing we do is we save EBP because we are not supposed to change EBP. And as a last thing we do, we restore the value of EBP. You can see the push and the pop, they are basically a pair. If I push first, I have to remember to pop it in most situations. The second thing we do is we take a snapshot of the stack pointers to make it into the frame pointer, because the whole idea of the frame pointer is it does not change when we continue to push, pop, and do all kinds of other crazy stuff on the stack. The frame pointer points to a particular point on the call frame, and it does not change. So we can use that as a constant, as a fixed point to refer to other items. Okay. And then what we need to do in this case is we also have to allocate for the local variable t, which means we have to adjust the stack pointer by that much. Okay, And remember, t is a negative number, so adding a negative number to the stack pointer is moving the stack pointer down, which means we are reserving more space on the stack. Are we doing okay so far with this program? Okay. So at this point, I'm going to stop. Okay, if this is my homework assignment, I would stop maybe right here, and then I would put a breakpoint on this instruction here, and then I would inspect the stack and see if I get everything right. Okay, but since I'm fairly sure this is okay, I'm just going to implement the instructions. The first instruction in C code is getting to whatever px points to and store that into the local variable t. So we only worry about one thing at a time. The first thing we worry about is the right-hand side. The right-hand side is dereferencing px, and px is a parameter. It is on the stack. So how do we do that? Well, there's no one single instruction that can do this. Okay, so you have to break it down into at least 2 instructions. The first instruction is to get the parameter itself on the stack into a particular register. I'm just using EAX here. Okay, and what is the addressing mode that I'm using here? What is px in parentheses, EPP? How do we call that? It's the base addressing mode. Very good. So the effective address where we are going to grab the 4 bytes to copy to EAX is based on the sum of EBP and PX as a label. EBP, the value of EBP changes when you execute the program. How did we get the value of EBP this time? Which instruction gives EBP a particular value? The move instruction. Move stack pointer into EBP. Okay? And PX is defined to be what? PX is return address plus 4. Return address itself is old EBP plus 4, and then old EBP is 0. So that will make PX 8. Yeah, it's the same thing as 8, but I will not put 8 in place of PX because 8 does not tell me which parameter I'm dealing with. PX does. Okay, so I can look at this code, look back into the C code, and I know what I am intending to do by looking at the assembly code. If I use 8, I would have lost track. I mean, I might remember 8 is the same thing as PX, but only for 5 seconds. A minute later, for sure, I would not remember, oh, what is that? What am I trying to copy into EAX? I would have no idea. Okay, but by using label, your assembly code now resembles your C code a little bit more, and it makes it easier to debug. Next, what do we do? What does EAX have at this point? Okay, I'll give you 2 choices. Is the integer the PX points to, or is it the address of the integer that is pointed to by PX?
The second one.
The second one, oh, I'd like that answer. Instead of repeating the whole phrase, which I cannot do, you just say the second one. Okay, it is the second one. So EAX itself is a pointer. But when you look at the C code, is the right-hand side the pointer, or is the right-hand side referring to the value that the pointer points to?
The value.
The second one, yes. I like that. B. Choice B. Yep. So when we do this, we have to, it would be nice if we can do something like this, because this is actually what I want to do, but there is a problem. I cannot do it like this. Why not?
Memory operands.
Because they're both memory operands. You can only have up to 1 memory operand when you have any type of instruction, with the exception of push. So what am I going to do with this? Let's see. What about doing it like that? Okay, so I dereference the pointer, store whatever it points to into EAX. Okay, it's not circular reasoning. This works just fine. Okay, then I can just move EAX, which is the integer pointed to by PX, into my local variable t, which is that. So these 3 instructions implement the first statement, like this. Okay. The second instruction, well, once you know how to get to the first one, second one is not really that much different. So we'll implement the second instruction, move py as a pointer into EAX again, move whatever whatever py points to into EAX. So now we actually have the integer pointed to by py, and we want to store that into px. Yeah, well, we can always use another register. I would not use EBX because EBX is supposed to be saved and restored by the subroutine. If you want to use EBX, you have to put a push and pop block around it so that the value does not change. In fact, I'm going to show you how to do that. Okay, so you say a push EBX here, and if I do a push, I automatically put in the pop and then insert the code in between, so this way I don't forget to pop. Okay, these are hard lessons that I learned from about 8-9 years of actual industrial programming. So if I say it is useful, it is at least useful to me. I'm not sure about you guys, but it's at least useful to me. It's worthwhile to do it this way. Okay. So now that EBX is saved and restored, I can now freely use EBX within the push and the pop, because as far as the caller is concerned, EBX is not changed because I save it first before I make any changes to it, and then I restore it using the pop instruction. So at this point I can use EBX, so I can say move PX EBP into EBX now, and then the value that I need to move into it is in EAX already, so I can now move EAX into whatever EBX points to, because EBX is PY, and is PX, sorry. So, and I want to store the value of register EAX into whatever PX points to, and since EBX is PX, indirect EBX will get me to that place. Are there any questions? These 6 instructions on the right-hand side implements the second line in C code. Yep.
Can you just say that last part again about the move instructions between push and pop for EBX? So you chose to use EBP because you can get to PX easier?
You mean EBX instead of EBP? No, I just want to show you guys how to use EBX if you need to use EBX.
Yeah, sorry.
Yeah, I could have used ECX or EDX without having to save and restore those registers. But I chose to use EBX because if someone wants to use EBX, you need to protect the value of EBX by putting a push and pop instruction around the block that makes use of the value. So this is just an example. I did not have to use it. Okay, any other questions?
Does using the push and pop use more resources?
Yes, it does. Because every single push instruction has at least one memory access, right? Because you're overwriting some content on the stack. And every pop instruction is reading something from the stack. So each one is at least one memory access, which is kind of costly.
So while this is more simpler for us to use.
It's not simpler. I just want to illustrate, if you do need to use EBX, this is what you need to do to preserve the value of EBX from the perspective of the call. You don't have to. There's no need to use EBX here because I got ECX and EDX as registers that I could have used. But I chose to use EBX because I want to show you, if you do want to use EBX, this is what you need to do. All right, so we are now on to the third instruction, or the third line in C code. Okay, once we know the first two, the third one is not too big of a deal. So we just take whatever t has as a local variable into EAX, and then we have to compute the address of where it's supposed to be stored, which is whatever py points to. So we'll put it into EDX this time. Okay, EDX does not need to be saved and restored, so that's why we don't need a push and pop around it. And this one is just EAX into whatever EDX points to. That's it. That's the entire code. Are there any questions about this program? I mean, this subroutine just swapped by itself at this point. Yep, go ahead.
Since the return value is void, it doesn't matter what's left in EAX?
That is correct. If EAX, ECX, and EDX can be modified in any way by the subroutine. But EAX has a special meaning to the caller if the subroutine is returning a scalar. But if the subroutine does not return a scalar, it's just ignored. Okay, very good. Good question. Yep.
On the can I look at the top of the program? On the how come t is less than 0?
Because it is allocated by the subroutine. It's a local variable. A local variable cannot be allocated by the caller. The caller has no idea of how many local variables are needed by the subroutine. So it can only be allocated by the subroutine.
Makes sense. Yeah, makes sense.
Okay. Any other questions? All right. So how do we know whether this code works or not? Right? I mean, that's the next question. So one thing we can do is we save this file, but in a different name. So I'm going to save it as swap.uppercase s. Save. Oh, write. There we go. Write to swap.uppercase s. And this time we have to export not main because we just have swap here. And then we go back to the C code here and just say, we need to keep the prototype, but we can now ignore the definition of the subroutine, like that. So now we have the main subroutine written in C as main.c, but we have swap as a subroutine implemented in assembly in swap.uppercase s. Now it's time to compile the entire program, gcc-o, we'll just call it main, -g because we want to include debug information. Main.c and swap.uppercase s are the source files, and gdb main. Okay, so this is a mixed code or mixed mode type of a debug session, which works just fine. Okay, so we want to put a breakpoint on line 16. Starting from the very beginning of main, we put a breakpoint. So single step, through these two instructions: print x, print y. No surprises here. Okay. Now we single step. So by single stepping into swap, it gets into the subroutine starting with the very first instruction. First thing we want to check is what is on the stack. Okay. We have the return address, and we have these two things that look like addresses. We have a strong suspicion. One is the address of x in main, the other one is y in main. Okay. Now before I proceed any further, if I have any doubt, I would verify that first. Okay. But how do I know that? There are two ways to know which one is x and which one is y. How do we know?
The order?
Hmm?
The order?
The order, yeah, well, but you don't know how the compiler allocates local variables. Because x can have a lower address, y can have a lower address. It's up to the compiler to decide how to allocate for the local variables. What about the value at these addresses?
You're 4 bytes apart.
They're 4 bytes apart, but which one is x and which one is y?
Look at that. Print it out.
Okay, tell me how to do that. This is an exercise for you guys to practice your GDB wizardry, yes.
You can print it as a char at that address if you just do print x, print/x, and then you put the address afterwards.
Well, if you use print, it is going to be in C, C++ mode, then you have to specify types. So if you do the print,
Command's easier, right?
yeah, the other way is easier, but you can do it this way too. That's how you do it in C, in using print, okay? I missed one F. There we go. So this one is 5, which is x in main, and then the other one is going to be 7, which is y in main. This is one way to do it. Second way, easier, x/wd for decimal, and then you supply the same thing, 0xbff f3bc 5, okay? The other one is b8, it is 7. Second way, right? Third way, there's one more, okay? The other way is actually more interesting, is to use backtrack, and then you go back to the first frame, you go back to frame 1. Now we are in the context of main. We can just say, hey, tell me what is the address of X, and tell me what is the address of Y. So 3 ways to verify what is on the stack in what order. They're all useful, okay, depending on the context. You know, which one you choose to use is up to you, but each one has its own merit and each one has its own value. Okay, any questions? No questions? Okay, if there are no questions, I am going to single step through all this code here. And you can see nothing is causing a segmentation fault. If I do have a segmentation fault, okay, now we're back to main, and we want to say, okay, tell me what is X. Oh, now X has the old value of Y. Tell me what is Y, and it has the old value of X. The swap subroutine, in fact, worked. Okay? But for most of you, if you were to implement a program like this, would it work the first time?
No.
And what would happen instead? 99% of the time, you end up with a segmentation fault. Okay? So if you do get a segmentation fault, what do? You quit. Should have done that earlier. Okay, so let's take a look at common problems that people encounter with this sort of thing. Okay? So I'm going to do well, we can display both code here, main and swap. Okay. Common issues. Forgetting about certain things, like forgetting to reserve the space for the local variable. What's going to happen if I forget to allocate a space for the local variable t? What do you think?
You won't allow it to access that memory.
No, it would still be fine. Okay? Actually, in this case, this program is going to work just fine without that line, but it doesn't mean it is correct. Okay? So let me show you what's happening on the stack here. So let's say this is memory for the whole stack, and I'm going to draw the point where we have allocated. So we got the 2 parameters here, right? We got the return address over here. We have old EBP over here. The stack pointer ends up pointing right here. Is that okay? So ESP ends up here, and then EBP is a copy of that. It ends up here as well. Now, this is without the adjustment, without the instruction that I just removed. So there's no additional allocation. When we get to the code that needs to use T, which is this one here, where am I copying EAX into? I'm still copying EAX into this portion here. But is it a part of the stack that is already allocated?
No.
Nope, because it's below where ESP points to. But in this case, the program will still work just fine. But in general, it's not a good idea. Why do you think that is the case? Why do you think it's still going to work here? Who else is going to use this location below where the stack pointer points to? Nobody.
Interrupts can be overridden? System interrupts can override it?
System interrupts would not override this, unfortunately. I wish it would, but it would not. Because in Linux, which is a protected mode operating system, the kernel has its own stack to handle interrupts. So whenever you have hardware interrupts coming in, it's actually going to use the kernel's own stack and not the stack of a user process. So that from the user's process perspective, the stack is okay. Nobody's going to use that space. In addition to that, swap does not call any other subroutine. If you have any other call to other subroutine, it's going to reuse this location for the return address at least. Okay, if not parameters, this location will be overwritten by a return address. So that's why in this particular case, the problem is masked. Okay, it doesn't mean it does not have a problem. It simply means it is masked. If I were to insert a printf statement somewhere in the swap subroutine, it would have broken this code. Okay, So that's why it is important to remember, if you have local variables, always make sure you allocate the space for it. Because if you don't, you'll be using a portion of the stack that is not allocated. Okay, any questions? This will make a terrific exam question. I have to make note to self. I have to watch my own video recording. Oh, that would be torturous. Okay, putting it back in. Okay, so let's see what else can go wrong here. Oh, what about this instruction? I forget to pop EBP before the return instruction. What's going to happen? Segmentation fault, okay? But what is the symptom of the segmentation fault? Can someone tell me, or at least give me an idea of how this program is going to crash because I forgot a pop L EBP?
You're not getting EVP back.
Okay, but what is the symptom? When this program does crash, what do you think it's gonna say? It's a segmentation fault, okay? But when you do get a segmentation fault, it tells you the location where you have the segmentation fault. So where do you think it's going to say, oh, we have a segmentation fault here because I'm not supposed to be able to execute over here? Think about it. This picture is important. We have old EBP, return address, parameters, and so on, okay? So with the proper exit sequence, it will pop this value back into EBP so that the stack pointer points back to the return address, and then it will use the return address on the stack to perform the actual return instruction. Everything is good. In this code, since I commented out pop L EBP, this will still be on the stack when I execute the return statement, which means the return instruction is going to use these 4 bytes as the location to go back to. So it will go back to which location? Well, give me a prefix of, what do you think is going to be the first 4 hexadecimal digit of that location? We have seen it many, many times today already. B, F, 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 blah, blah, blah. Okay? Well, let's see if that's what's going to happen. Okay? So we'll go ahead and GCC again, GDB main. And I'll just run the program at full speed, not even putting a breakpoint here, because I want to see how it crashes. And what do we see? Segmentation fault, and this is saying that it is attempting to execute at this location. It is the instruction at this location that is causing the problem. But it makes sense because it is using the value of OEBP as the return address. So it makes perfect sense that it is going to crash like this. Are we doing okay so far with this? Okay. All right. I am really trying my best to help you debug your program by showing you the common problems that people encounter. Okay, so let's see how else can we mess up this program. Okay, go fix that problem first. Okay. Maybe misunderstanding the pointers. Okay, so maybe misunderstanding the PX is already, we don't need an indirection. Okay, so we'll say that we misunderstand that PX EBP is getting to the value of the value pointed to by PX already, so we forgot to do one indirection. What do you think is going to be the symptom of this code?
It's going to return a wrong value. It's just going to have an address instead of value.
But which variable is going to be messed up? If this is the only mistake that I'm making in this subroutine, from the caller's perspective, from main's perspective, which variable would end up with a gibberish value? Well, it depends on how T is used, right? T is used to overwrite what PY points to. So that means in main, y would not end up with a value of 5, which is what it should have, but instead it would end up with hexadecimal b f f f f blah blah blah, which is going to be a huge, which is going to be a negative value, but it has a really big magnitude as well. Okay, so that's the symptom of doing something like that. Yeah. Okay, very good. And let's see how else can we mess up this program. But what I'm trying to do here is to show you guys, what happens when things go wrong. Okay. Any other issues that you guys have encountered that you cannot explain? I suppose we can wait until the lab time for that sort of thing, but general questions? Anything related to? Yep, go ahead.
The function call within the assembly language program, is that the same way you do it in C?
Same way you do in C. So let's go back to the program that we are supposed to write. strdcpy. Okay, so you're talking about this call here, right?
Right.
So what do we need to do is we have to push this on the stack first, push that on the stack second, because whatever you push last is the first, has the lower address, and then you just call the subroutine. When the subroutine returns, look at EAX. Well, remember to deallocate the space that you use for the parameters, because we don't want to waste space unnecessarily.
Okay.
Yep. Go ahead.
Did you just run a disassembler to look at the assembly code for this?
You can, but it's not going to be helpful. Because, well, okay, it is helpful to understand how things are supposed to be done, but in the exam, because if you do it that way, you have an understanding, you can see the code generated by the compiler, but it will contain instructions that we have not talked about in this class, for one thing. And the second thing is it doesn't help to train your own strength of synthesizing code. So in the exam, it's not going to be as helpful. Okay. And I can spot that sort of thing too. Okay. Any other questions? No other questions? I think last time I demonstrated string copy already. How to use. Okay, I'm pretty sure I did that. String. Let's see. I think I did string compare, not copy, but that's pretty close. So I'm gonna just let you guys take a look at this again, because I think some of you might have forgotten. Based on the questions that you asked today, I think some of you may have forgotten what we did on last Thursday. So any questions about this part? This is what we did last Thursday. On the left-hand side, we have string compare implemented in C, C++, whatever you want to call that. Okay. And then on the right-hand side, we have the actual code implemented in the same code but implemented in assembly. So are there any questions about this particular example? No questions? You guys want another example, like how to implement string char itself in assembly, which you don't have to? Okay, all right. So let's take a look at string char. Okay, the first thing we want to do, I don't think I have it installed, so yeah, that's not gonna work. That's okay, you can easily Google that, because string char is a very well-known C++ or C string function. So we want to understand the behavior of the string char function first, do it in C, and then we will convert it into assembly. We got enough time to do it. Okay, so this is string char, and you can see what it does. Okay, it returns a pointer to the first occurrence of quote-unquote character, which is the name of a parameter in the C string str. When they refer to a string as a C string, it means it is a null terminated string. Okay, that's basically what it means. The terminating null character is considered part of the C string, and therefore, if character itself is null, it will match the end of a string. Okay? Does everybody understand what that means?
Yeah.
Okay, very good. All right, parameters. str is a C string, which means it is a pointer to a character, and character is an integer, so we know for sure it's going to take up 4 bytes on the stack. Is the character to be located? It is passed as its int promotion, which means it is going to be a 32-bit value, but is internally converted back to char for comparison. So we'll be using what CMP instruction? CMP L, W, or B? B, because a character, a char, is a byte. Okay, very good. The return value is a pointer to the first occurrence of character in string. If the character is not found in the string, the function returns a null pointer. What is a null pointer? 0, very good. All right, so we know the behavior of the C code, so the first thing we do is to write the C code first. Yep.
Question. What is the reason for sending a character as an integer?
To keep the stack aligned. We talked about that last time too.
Okay.
All right, so we'll go ahead and implement this function first in C. Okay, it returns a const char pointer because the first parameter is a const char pointer to begin with. So this is our str, our string, and then we have the character to be found. I hate to type all that, but since that was the prototype used by the man page, I'm going to be consistent with that. Okay, so how do we do this?
We check
Okay.
the byte of the character with the value of the first character.
Okay, so let me kind of go through my own mind and tell you guys how I would approach this. The first thing I do is I say, there's a loop. No, actually, the first thing I do is, can I do this in recursively? The answer is, yes, I can do it recursively. But do I want to do it recursively? Not yet, okay? But it can be done recursively. In fact, I would say the recursive version is, in a way, easier than the iterative version. Yep.
Isn't the question is, can I do it in a loop first and then?
Nope, it depends on how you think.
Really?
The two approaches are equivalent in all ways.
Yeah.
So it is based on how you usually think. Since I am a deferrer, I like recursion.
Defer, what is that?
I like to defer something to somebody
Oh,
else to
okay.
do. Or later, okay?
Yeah.
Procrastinator. So
Isn't-
recursion is the procrastinator's best friend.
Yeah.
So tell Mr. Fox that. It's not a programmer's best friend, it's a procrastinator's best friend. Okay, so we'll do it without recursion first, okay? So, start with the while, okay? So we say while whatever str points to is non-null. Okay, that's the first criteria to stay in the loop. What is the second criteria to stay in the loop? Whatever it points to does not equal to what I'm looking for. Okay, so this means the first one means it is not the end of the string. The second part means I haven't found what I'm looking for. That's why I'm staying in the loop. Yep.
Don't you have to typecast that?
Nope.
Character?
It's automatic.
No.
C and C++, this is called what? What feature of the C compiler would do this automatic type conversion? Because character is an integer, but whatever str points to is a, no, character is an integer, 32-bit, and then whatever str points to is a character. So these two things do not have the same width. There's a feature in C++ or C and C++ that can automatically promote one side to make it the same width as the other side. What is the name of that feature? Coercion. They should have named that thing in C and C++ in CISP360. Coercion. Yep. Okay, so what do we do in the loop? If whatever str points to is not the end, and whatever it points to does not match what I'm looking for, what do I do? Try to look at the next thing, right? In the next iteration, how do I move on to the next thing?
You increment the pointer.
Right? That would do it. All right, so eventually I'm going to exit the loop. When I do exit the loop, what do I do? Yep.
Oh, is there a big difference between the str and str++?
There's no difference in this case because nobody is using the actual value of the expression. So we are only using the side effect of the operator to add one to the pointer. Okay, so what do we do after that? We have to do a return, right? Because this one does have a non-void return value. What am I going to return?
We need to check if it's the last character.
We need to check something. But I insist on using a return right here and not to use a conditional statement. So what do I do? Ternary operator, right? Ternary operator looks like this. Expression, question mark, expression, colon, expression, which is a conditional expression, right? The first condition. So what do I use as a condition? How do I decide whether I found the character or not?
str equal character?
Not exactly that, okay? If you did something like this, the compiler will scream at you.
The dereference str.
Very good. So now the compiler won't scream at you. Okay, so what if that is the case? This is the value of the ternary expression if the first expression is true. So what do I specify here? No. str. I found it. This is where the character is in the string. The other one is a 0. Hold on a second here. The compiler is going to scream again because 0 is an integer and the return type of this thing is supposed to be a pointer to a const char. Nope, it's not going to scream. Because 0 is one of those things that spans across different types. Okay? So 0 can be used as a pointer without casting. It's one of the very few things that can be used in this context. Okay. Of course, I am not really quite sure what I'm talking about, so we'll double check. Well, it complains, but it's not because of that. It says expected identifier. Oh, duh. What is the name of the subroutine? That is so typical of me. I forgot to specify the name of the subroutine. No wonder the compiler is not happy about that. Okay, now we'll go ahead and GCC again. Not a problem. Attack, you did not turn on warn all. Maybe that's why. Not a problem. Maybe you forgot to turn on pedantic too. Pedantic. Not a problem. So this tells you that 0 is special. The type of 0 can be automatically morphed into anything scalar. Okay, so it can be char, integer, even pointers. Okay. Any questions about the C implementation of string char?
Do you really need the ternary operator? Like, because if it gets to the end of
Yes, you do, because you're not returning the null character, you're returning a null pointer. So you do need that because the pointer is non-null. It is just pointing to a null character if you exit loop not finding what you're looking for.
Okay.
Yep. That's a good question, but yeah, you still need a ternary operator. Yep.
Is there any functional difference between the if-else statement and the ternary operator?
It's just more concise.
Okay. But functionally, it's the same thing.
If you use a conditional statement,
if I use a if-else.
yeah, it's just lengthier and.
Makes sense.
Okay, let me ask you another question. If you use a conditional statement, are you going to put returns into the branches?
Yeah.
That is not a good idea. Okay, putting return statements inside any type of control structure, anywhere other than the end of an entire subroutine is usually not a good idea.
Why is that?
Because it changes the way you can no longer analyze a program in a more mathematical structured way.
Okay.
Because there are ways to get out of the entire program without going through all the control structures.
Okay.
So that's usually considered not a very good programming practice. Yep. Okay, so let's do a V split here because I want to do this in assembly. Okay, so I want to edit strchr.uppercase s. This is the assembly version of this code. strchr. Okay, this is the usual way I start this because these two need to be here. For people who write sequentially, okay, I used to do that. Sometimes I would forget the RET instruction at the end. And what would that do?
Keep going.
It will keep going to the next subroutine. So depending on how the program is linked with other library subroutines, it may be printf right after this. It may be something completely unrelated to your code that is after this. So the symptom is going to be very strange, and it will take you a long time to find this. So from here on, I just do things in this way. Basically, if I start something, I would end it. Of course, this seems like unnecessary typing or unnecessary cursor movement because I have to go back and forth all the time. But this way, I don't forget to close something. Okay, it's just, for me, it is worth the trouble of moving the cursor a few times. All right. So the next thing we want to do is to give names to the parameters. But these names are not really the actual parameter. They are displacements from where EBP points to the parameters. So I have the usual stuff, OEBP. You don't have to do it the same way that I do because some people say I don't need to define 0. Okay. But I just like to remind myself how the stack is arranged, because if I'm taking this class as a class, I would want to understand and make sure that I understand how things are arranged on the stack. This is a good reminder. There we go. So now we have all the parameters and usual stuff set up. There are no local variables here in the C code, and I don't think I will need any in the assembly code either. All right, do you guys want to do this the quick way, which means I'm gonna use a register as str, or do you want to do it the long way, which means the assembly code is really mirroring the C code? The long way? Oh, okay. Let's take a vote. Short way. How many people want the short way? We got 4, 5, 6.
It would have to be the less than 4 minutes way.
Oh yeah, that's fine. We have the lap time too. Okay, long way. I think, unfortunately, the short way has it. Okay, we'll do the short way. Okay, the short way is to move the pointer into a register. So I can use EAX if I want to. It's not a big deal. And I'll move the character, which is the second parameter, into ECX, so I don't have to save and restore EBX, which is a chore. Okay, now I need to specify the loop. So we have while begin, JMP to while begin, and while end. Okay, so you can see how I define the beginning and the closing of the construct. Now we need to specify the condition. So CMP blah $0 to whatever EAX points to, because that's my str, and JZ to exit while end. Okay, tell me what question mark should be. B, because it's comparing a character. Very good. Next, we have comparing the character to whatever string points to. So what do I do with this? Okay, CMP B again. And this time one is in CL, and the other one is still in ECX, or whatever ECX points to. And if they are the same, we also get out of the loop. In the loop, I am going to increment the pointer, which is just adding 1 to str. But remember, I don't want to add to str anymore because I took the short route, which means EAX register EAX is doing the same thing as str. Are we doing okay so far with this code? Okay, all right. After we exit, we have to specify the return value. We have a ternary operator here, which means we have one extra compare that we need to do. So we'll go ahead and just compare byte, CL, which is the character that I'm looking for, with whatever EAX points to, which is actually str, whatever str points to at this point. And if they are the same, we also get out of the loop. In the loop, I am going to increment the pointer, which is just adding 1 to str. And if they are the same, we also get out of the loop. So and we'll say J. Well, I'm going to preserve the same structure of the code here. So we'll have the else case being not matching, J and Z, to the ternary else, okay? And I will specify the else here, which also means I need to specify a unconditional branch here to the end of the if, and specify the end of the if over here. Okay. But you can also see, how I structure my code. When I implement the construct, I will implement the skeleton first, and then go back and fill in the details of the skeleton. Okay, so in this case, when I get here, it means whatever str points to, okay, I just put the equal here. If it's equal, then EAX is already the correct value to return, nothing to do. Or for those of you who prefer to say, but there's always something to do, fine. Do that instead. Okay. Or you can say no up, okay? For those of you who insist, there has to be something in the then branch. Okay, put something in the then branch. Fine, not a big deal. Okay, in the else, we do have something to do because the return value is always in EAX, so we have to put a 0 into EAX. Done. With at least 30 seconds to spare. But I didn't get to the recursive version. Got to get that done too. Okay, recursive version. Okay. It's easier than what you think. Okay. What is the terminating case? Terminating case is, this is a null. Let's see. Nope, the first one is it matches. Okay. So if whatever str points to is in fact character, then I have a return. But since I said do not use return within a conditional statement, so I'm going to say const tar result here. Result is just str because this is where the character is. Okay, else. Okay, what else means is they do not match. Okay, if they do not match, I got something to check first. Because if str is pointing to a null character, then I'm done. Because I'm at the end of the entire string, there's nothing else to do, and yet I have not found what I'm looking for, so I should return 0. This is the place where I do the recursion, because I haven't found it yet, but I'm not at the end of the string yet either, so I'm going to have someone else to look at the rest of the string for what I'm looking for. So that means my return value is the return value of the next guy who is responsible to look at the rest of the string, which is str plus 1, because whatever str points to is already taken care of. The next guy can start with the next character, but what the next guy is looking for is the same thing that I'm looking for. Recursive version, almost done. Don't forget that. Now, can we turn this into a compound or nested ternary operator? That would make an excellent final question. It's a function with only one return and nested ternary operators inside, and you are going to convert it into assembly code. Or, better yet, I turn it into assembly code with mistakes, and you have to spot those mistakes. That makes it easier to grade, so that's why I like the second option better. I'll see you guys at the lab for those of you who want to work on this at the lab.